Hi everybody, this is sections 12.1 and 12.2 for Math 102 Contemporary Math from our Thinking Mathematically textbook. And 12.1 we're going to look at sampling, frequency, distributions, and graphs. Chapter 12 deals with statistics, so we'll look at all different things related to statistics in this chapter. All right, so in statistics, what statistics is just a method of collecting, organizing, and analyzing and interpreting data. And then we use this data to draw conclusions, and then those conclusions can be used for, different deciding in business, should we do something or not do something? In education, is a certain objective being taught properly or not being taught, or do we need to work with it? Descriptive statistics is collecting, organizing, summarizing, and presenting data. And then inferential statistics is making generalizations about and drawing conclusions from the data collected. So descriptive statistics, you're organizing, collecting, and summarizing and presenting the data. But then when you have inferential statistics, you are making conclusions from that data that's collected. All right, so when we do a study with statistics, you do have a population, and that is the set containing all people or objects whose properties are to be described and analyzed by the data collector. So if I'm doing a study for math students at Harvard, the population will be all students taking a math class at Harvard. Within that population, you're going to have a sample, so that's a subset or a subgroup of the population. So I may not be able to, survey or study all of the math students at Harvard, but I can take a sample of those students. And then a representative sample is a sample that exhibits characteristics typical of those possessed by the target population. All right, and so here's just an example. We have a study that needs to be done, and there's a group of hotel owners that are in a large city, and they want to conduct a survey among citizens of the city to discover their opinions about casino gambling. So the population that they are going to look at for this study is going to be all the citizens of the city. They want to survey them to see how they feel about casino gambling. Now, they know they need, the population is all of the citizens of the city. So they can't survey every single citizen of the city. So they have to find a representative sample. And one of the hotel owners suggests they can obtain a sample by surveying all the people at 6 of the largest nightclubs in the city, and they're going to do this on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? And you can see down below, think about this. They want to survey the citizens of the city, but they are going to go into 6 of the largest nightclubs on a Saturday night and survey all of those people. This would not be a good representative sample of the population because they're surveying everybody at a nightclub on a Saturday night. Those are going to be, probably people that are more favorable towards gambling or casinos because they're favorable towards nightclubs and going out on a Saturday night. That could be one subset. They could survey one of the nightclubs maybe, but then they also have to get people from other areas of the city or, other parts of the city. They don't want to just survey the people at the nightclubs. You could select people to survey by random sampling, and a random sample is obtained in such a way that every element of the population has an equal chance of being selected for the sample. So we're talking about the people in the city. One way you could do this, if we were looking for surveying about the casino, is you can assign numbers to every element of the population. So you could assign numbers to the people in the city, which is a little bit hard, but maybe to the houses in the city, and you could randomly select those numbers. And those will be the people you survey. oftentimes you'll hear they go through like the phone book and they choose every 8th person, and that's who they're going to survey. But just random sampling, people are picked at random. You could, survey people at a mall, and you just pick every 5th person walking by. But again, if you do it at a mall, you have a certain type of person, so you want to make sure you go on alternate days and at different times of the day, so you're not just there in the evening, on a Sunday night. You want to make sure you're there in the morning, the afternoon, and the evening, and, you pick like every 5th person that walks by or something similar to that. All right, so now we're going to look at different ways to randomly select the sample to survey the city's citizens about how they feel about casino gambling. The first suggestion is to randomly survey people who live in the oceanfront condominiums of the city. Now, there, you're you're being very selective about the people. You're looking at only those oceanfront condominiums. The city may consist of those condominiums, but then there are single-family homes. There are other apartments, townhomes, with not at the oceanfront. So again, you're not having a very good sample here. And, those people along the oceanfront, if the hotel or the casino is going to be there, might be object to that because they don't want the noise. So again, not a good random sample. So the next suggestion would be to survey the first 200 people whose names appear in the city's telephone directory. Again, you could survey 200 people, but you don't want the first 200 names because then you're getting probably all the A's and maybe some B's, but then nobody else. So you're not really getting a good sample of people. You could survey every 8th person in the phone book, every 9th person, and that might be good. And then the last way is to randomly select neighborhoods of the city and then randomly survey people within those selected neighborhoods. And again, you're sampling, you're taking all the neighborhoods of the city, you're putting them into one, kind of think of it like you're putting it into a hat. You're drawing out a neighborhood. You're going to randomly select people in that neighborhood. So that is a good random sample of the city, and you should get a good cross-section of different types of people and their opinions about how they feel about the casino. All right, the next thing that we're going to look at is constructing a frequency distribution chart. And what a frequency distribution chart is you sometimes get a set of data and you're going to have a lot of numbers on there. And when you're given that data and it looks like a list of numbers like it does right here, that is for 35 boys. So it's a little hard to just look at that data and extrapolate any information from it. So what you want to do is you're like, okay, well, let's look at the information and organize it. So we are looking at the age of maximum yearly growth for 35 boys. So what I'm going to do what they did is they made a frequency distribution chart. So they said, okay, what's the youngest age? And we can see, looks like 10 is the youngest, and the oldest that they have is 18. So we listed the ages 10 through 18 right here, and then they wrote the frequency. There's one boy that reached the maximum yearly growth at age 10, and then 2 at 11. And what I would do to get this set of numbers right here is, before I do that, I typically I'll do tally. So I'll go through the list and I'll say, okay, there's 12. So I'll put a tally mark there. If it helps you organize it, you can do that. 14, and then there's 13, another 14. And that way, you don't have to go through the list and count. You can make the tallies and count those at the end. But as you can see, here with my frequency chart, it organizes the data, and then from that, I can use the data to answer questions that I need to. So if we look here at the frequency chart, we can tell the maximum growth for most subjects occurred between the ages of 12 and 15, because that's where we have our highest numbers or 5, 7, 9, and 6, between the ages of 12 and 15. And most boys in this, boys that were surveyed, reached their maximum year of growth in year 14. So we had 9 there, and then, there were fewer after that. But the peak was at 14. All right, and here we have the test scores for a group of statistics students, and there were 40 students in the class. And if you look at these scores, you can see they kind of go, there's a lot of different scores, and they go all over the place. And here, maybe listing out all the scores and making a tally isn't going to be as helpful as looking at them in what we call a group frequency distribution. So we're going to group them by first, 40s, then 50s, then 60s, 70s, 80s, and 90s. Because really, you want to look at those, maybe those E's, those B's, those C's, those D's. So instead of just putting a tally next to each individual score, we're going to make a grouped frequency chart. And we're going to group all of the 40s together, all the 50s together, all the 60s, 70s, 80s, and 90s. Right, and here you can see they took all the scores and they grouped them. There were 3 scores that were in the 40s. You had 6 in the 50s, 6 in the 60s, 11 in the 70s, 9 in the 80s, and 5 in the 90s. Now, when we look at this, 40 to 49, that is, you have 10 numbers between 40 and 49, or 40 to 49 is 10 numbers. So the class, it's called the class width, because this is the class, is 10. So it's really how big your width, your span of numbers is. When you have a grouped frequency chart, all of your classes should be the same width. They should not change. The lower number, the lowest number is called the lower class limit, and the highest number is called the upper class limit. All right, and what we have here, using that information, we can create different charts to help us understand the information. So they took here the boys' ages of maximum yearly growth, and they made 2 different charts. They made a histogram, and a histogram looks very similar to a bar graph, but a histogram is a bar graph with bars that touch, and they can be used to visually display the data. And the reason it's different from a bar graph is here for the x-axis, we're talking about ages. We don't have different types of items. They're all ages. They're just different numbers. So that's why the bar graph is a histogram and it touches. If this was a bar graph looking at like the number of pets you have, and you had cats and dogs, then because they're unrelated, a cat isn't a dog, the bars would not touch. But because we're talking about all all ages, the bars can touch. And then using that histogram, you can also make a frequency polygon. And that is a line graph. So if you notice, there's the line right here. No, I'm sorry, I'm not a very good drawer. Connecting, and what you do is you put a dot in the midpoint of each bar of that histogram, and you connect it, and that will make your line plot. All right, next we're going to look at another way to organize data. We can organize data by using a stem and leaf plot. And a stem and leaf plot is a way to look at, where your numbers are kind of grouped. It's similar to a grouped frequency chart, except now you can look at all the numbers in the group. So we don't, with the group frequency chart, we knew there were 3 people in the 40s, but we didn't know what their scores were. If you want to know the scores and where they're grouped, you can do a stem and leaf plot. And if you recall, a stem and leaf plot has 2 parts. So one side you have your stems, the other side you have the leaves. In this case, because we're all dealing with 2-digit numbers, the stems will consist of my tens digits, And the leaf will be the units digit. So here, the first thing you want to do is find the lowest and the highest values. Let's see here. I do see there's a 43. I don't think I see anything lower. And then my highest is, I do see 94. I think that is the highest. But it goes to the 90s. So my stems, I know, need to start in the 40s. And then you want to, because you start with the 4, you want to continue. You don't have to put 0 through 3 because we don't need them. But we do have to put everything between 4 and 9, even if it's not a number that's used or a 10 that's used. So we're going to do 5, 6, 7, 8, and 9. And then from there, you just go and list your leaves. They do not have to be in order, but I usually do a rough draft and then go back and reorder it so I can put the leaves in order. But here I have 82, so I'll go to my 8 and put my 2 there. 47, so I'll put my 7 there. 75, put that there. And you want to try to keep that first row or column of numbers in order. 64, so I'll put my 4 there. 57, 82, so another 82, so I'm going to put another 2. Between numbers, you will not put commas, you just leave a little space between the leaves. Then we have 63, 93, 76, and then you would just keep going through the list and putting in all of the leaves to get your stem and leaf plot. One other thing that you do want to add is a key. So, for the key, I would say like 81, and I would draw the stem and leaf plot is equal to 81. So 8/1 is equal to 81. And here you can see a completed version of the stem and leaf plot. And again, you'll notice the leaves are not in order here. They do not have to be in order. You can, if you want, put them in order. But really, you're just looking at the data. And here I can see that through this information, most of my numbers were in the 70s. I can look at it right away and say most of the numbers were in the 70s. We also had a lot that were in the 80s. And then, from there, it kind of drops off a little bit, but we have the 50s, 60s, and 90s. But most of my numbers were in the 70s. The next largest group was in the 80s. Now we're going to look at section 2.2, and we're going to look at the different measures of central tendency in this section. All right, the first measure of central tendency that we're going to look at is the mean. This is probably one that you're pretty mostly familiar with, and that is our average. Another name for it is average. And again, to find the mean, you take the sum of all your data items and divide it by the number of items that you have. And this represents the sum of all the items. All right, so here we have a chart, and it is a chart where they have surveyed adults in 10 selected countries, and they want to know, are inventors born or made? So the survey shows a wide agreement that inventiveness is a quality that can be learned. So they want us to find the mean percentage of adults in the 10 countries who agree that inventiveness can be learned. So if we look, inventiveness can be learned is in the teal. So we need to take and add up all of these percentages, and there's 10 countries, and divide it by 10. So here you can see that if we take all of those numbers in the teal, and add 92 plus 84 plus 84 plus 80 plus 78 plus 77 plus 77 plus 75 plus 75. You get 799, and then we'll divide it by 10 because there were 10 countries that were looked at. And that gives us an average or a mean of 79.9% of people think that inventiveness can be learned. Now, there will be times when you are calculating the mean and you are using a frequency distribution chart because you had a large amount of numbers and a lot of data points repeated themselves. So to do the frequency, the mean from a frequency distribution chart, the first thing you're going to need to do or know is X will represent the data value. So, if we were talking about the countries again, it is, really that's not a good one. Let's say we're talking about test scores. So X could be the test score. F will be the frequency that test score occurs. And then here we have the sum of X times F. So you're going to take the data point times the number of times it occurs, multiply it, and then add all those numbers together. And then we are going to divide that by N, which is the total frequency of the distribution. So here we have a frequency distribution chart. And this table shows students' responses to the question, how stressed have you felt in the last 2.5 weeks? That's a big question, and a lot of people can relate to this. They gave a scale of 0 to 10, with 10 being super stressed and 0 not as stressed at all. So they want us to find the mean stress level ratings. All right, so what we are going to do is we're going to first thing you have to do is take your X or your stress level and multiply it times your frequency. So if I do 0 times 2, that gives me a 0. 1 times 1 will give me 1. 2 times 3 will give me 6. 3 times 12 is 36. 4 times 16 is 64. 5 times 18 is 90. 6 times 13 is 78. 7 times 31 is 217. 8 times 26 is 208. And then 9 times 15 is 135. It's not very good writing. 10 times 14 would be 140. So now we have the data value point, the stress rating, times the frequency. And now what we need to do is we're going to add all that up. And when we add all of that up, we add all of these numbers right here. We are going to end up with 975. And then we need to figure out N, and that is the number of frequencies. So really to get N, what you need to do is you need to add up all those numbers. So when we add up all of those, that is going to be our N, and in this case N is equal to 151. So to find my mean, I'm going to take 975 divided by 151. So the mean or average stress level for the people surveyed was a 6.46. Not bad. I feel like in today's world, that's a pretty good indication of stress level. All right, now we're going to look at the median. And the median is a data item that is the middle of the set of the orders, or the data set, or data points, I guess. And so in order to find the median, you do have to have your data listed from lowest to highest. And then if you have an odd number of data items, the middle number is the median. But if you have an even number of data items, then you have two numbers in the middle. So what you have to do is find the mean of those two numbers. So you would add them up and divide by 2. All right, so here we're going to find the median for this set of numbers. So the first thing we need to do is list them in order from least to greatest. So we have 84, 88, 90, 95, and 98. This is a fairly small set of data points. There are 5 of them, which is an odd number. So then that means that my median, or my middle number, is 90. So right here, again, we want to find the median. So the first thing we have to do is list them in order from least to greatest. So it looks like, 7 is my lowest. And then we have 13, 15, 25, 28, 34, 47, 59, 68, and 74. And let's see here. How many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have an even number. So that means we're going to have 2 numbers in the middle. So sometimes I like to just start from the outside, work my way in, cross off 1 in the front, 1 in the back. All right, and when I do that, then I get to these 2 numbers in the middle. So I have 28 and 34. So what I need to do is find the average of those 2 numbers. So I'll add them together. 28 plus 34. 8 plus 4 is 12. 2 plus 3 is 5, plus 1 more is 6. So now we have 62 divided by 2, and that gives me a median score of 31. Now, sometimes you're going to have a large list of numbers, and it might not be the easiest to find that middle number or those middle 2 numbers. So there is a position formula that you can use to find where that middle number is. So you kind of know, once you have an order, you can count right in. And that is, what you're going to do is you're going to take the number of items. So n, add 1 and divide by 2, and that will tell you where the median number is. And again, this is helpful when you have a large list of numbers, so that, if you have, 235 numbers, to find that middle part, it could be a little cumbersome, but if you use the position formula, it will help you find it quicker, so you know right where to go to find it. All right, so we are back to our chart where we are looking at the stress level of the students surveyed. And if we recall, there were 151 data points there. And we want to know what's the median. And again, this is a frequency distribution chart. So there's a lot of numbers. There's a lot of zeros. Well, there's 2 zeros. But like when you get to 5s, there's 18 of them. And it would be a lot to list it out. But using that position formula, I can take my 151, add 1 to it, so we get 152, divide by 2, and that tells me that the median is in the 76th spot. So what that means is we have to count down in my column until we get to the 76th spot. So what I'm going to do is I start here. I know I have 2 zeros. Plus 1 will give me 3. Now, if I add another 3, right now I'm at 6. So I'm at the sixth spot. 6 plus 12 will give me 18. So I'm at the 18th spot. If I go through 0, 1, 2, and 3, I've listed 18 of the scores so far. If I take 18 and I add 16 to it, that's going to give me 34. So I'm getting closer to 76. Not quite there yet. If I take 34 and I add 18 to it, that is going to give me 52. So I'm getting closer. If I take 52 and I add 13 to it, I get to 65. And then if I take 65 and I add my 31 to it, that gives me 96. So that means that from 65 all the way through 7s is 96 spots, but I only need the 76th spot. So that means that 7 right here, that 76 is going to be within that 31. So 7 is my median for this frequency distribution chart. And here's just another visual to show you them counting down on that frequency distribution chart. And they list out those numbers. So if you didn't quite understand what I was saying, this is a good visual chart to look at. All right, and here, we have the measures of central tendency, and there are different measures. And, sometimes when you're using data, you want to use the mean, sometimes you use the median, sometimes the mode. And here we're just going to compare the median and the mean. So we have 5 employees at a manufacturing plant. They earn salaries of $19,700, $20,400, $21,500, $22,600, and $23,000 annually. And the manager has an annual salary of $95,000. So they want the median salary for the 6 people. So first, they arrange them in order from least to greatest. And there are 6 people. So that means we have an even number. So the middle 2 numbers are going to be my $21,500 and $22,600. So when we find the average of those two, the median salary is $22,050, which seems fairly good for a representative there because, most of the salaries are in that range. Now, if we were to look at the median for those 6 salaries, if we take the 6 salaries and we add them up and divide by 6, when you add them up, you get $202,200 divided by 6, and that gives us a mean of $33,700. And really, when you're looking at this, that $33,700 is not a very good representation of all of the data points, because most of them, are right in that $20,000 range. There are no salaries that are $33,700 or that aren't that close to it. Now, what kind of skewed the mean a little bit is we had that one large annual salary of $95,000, and the rest were lower. So that $95,000 made the mean a little bit higher. So, the mean in this problem probably isn't the best data point to use. All right, now we're going to look at the mode. And the mode is the data value point that occurs the most, or the most often. Now, with the mode, you can have no mode. If all the data points occur only once, there would be no mode. Or if you have some data points that occur more than once, but they occur the same amount of times, then you can have more than one mode. You could have 2 or 3 or 4 modes. So if we look here to find the mode of our set of data, we have 7, 2, 4, 7, 8, and 10. And in this set of data, we notice that 7 occurs twice. It's the only number that occurs more than once. So here, my mode would be 7. All right, the last measure of central tendency that we're going to look at is called the mid-range. And this is, you may have heard of the range before, but it's a little bit different than the range. The mid-range is found by adding, so you're going to add the lowest and the highest data values and dividing the sum by 2. So the mid-range, you add the lowest and the highest values and divide by 2. All right, so we have Newsweek magazine. They examined factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown on the next slide. And they want us to find the mid-range among the 12 best countries to be a woman. All right, so we are looking at the 12 best places to be a woman. So we want this column right here. And we are finding the mid-range. So the highest score was 100. The lowest was 87.2. So we add the highest and the lowest together and divide by 2. So 187.2 divided by 2. The mid-range for the best place to be a woman, the best country, I guess, is 93.6. And that is all for section 12.2.